Here's part 2 of the Trig Identities and Formulas notes. I'll do examples 4, 5, 6, and 7 in this video. First one, the directions say to simplify to a trigonometric function of a single angle and then give the exact value. So what you're given is this expression, the cosine of 50 times the cosine of 140 plus the sine of 50 times the sine of 140. So we don't know the cosine of 50. It's not one of those automatic values. So don't go to a calculator. I want you to get the exact value, all right? And so that means you're not going to use a calculator. You're going to use these patterns. Look carefully at this. Let 50 degrees represent like the first angle, alpha, and 140 degrees is a different angle. Let that be beta. So really we have something that fits the pattern of like a cosine of alpha, cosine of beta, plus the sine of alpha times the sine of beta. Because the same angle shows up here and here. These are both alpha and these are both beta. So you're looking for something that fits that pattern. Cosine of alpha times the cosine of beta plus, okay, so it's got to be this one. We're looking at this pattern. If you really study it carefully, this problem fits the same pattern as cosine of alpha minus beta. Okay, look it over carefully. It matches up exactly. So this would be equivalent to the cosine of the first angle, 50, minus the second angle, 140. So we just write that out as the cosine of 50 minus 140. Well, the 50 minus 140 is negative 90. So it'd be the same as the cosine of negative 90 degrees. So that is the first part. We got it to a trig function of a single angle. That's part 1. And then give the exact value. The second part is evaluate this. What's the cosine of negative 90 degrees? Well, remember what it means from that big table. To have a negative angle just means you measure the opposite direction. If this is 0, going negative 90 degrees takes you there. Same relative position as positive 270. When the cosine there is 0 because you haven't moved in the x direction. Remember, cosine is related to x. So if you have not moved to the left or to the right, but you move straight down, that means the cosine of negative 90 degrees is 0. So that would be your answer to the second part. Okay? Same idea here with number 5. Simplify to a trig function of a single angle and give the exact value. Sine of pi over 3 times the cosine of pi over 12. There's one angle, there's a different angle. So call that alpha, call that beta. So if this is sine of alpha cosine beta, this would be the cosine of alpha times the sine of beta. We're looking for that pattern. Sine of alpha times the cosine of beta. That happens here, and this top one. But then we need a minus sign. This one is a plus, this one is a minus. So for this example, we're using this function, this formula. So this would be the same as the sine of alpha, which is going to be replaced with pi over 3 this time, minus pi over 12. This is like the sine of alpha minus beta. Okay? So what we were given something that fits this right side, so we just write it as the left side, substituting pi over 3 for alpha and pi over 12 for beta. All right? And now we can just evaluate that. So pi over 3 minus pi over 12, we could combine those if we changed into a common denominator, which we could make 12 the common denominator. So we make that 4 pi over 12 minus pi over 12. That's the same as 3 pi over 12. And 3 over 12 reduces to 1 over 4, so that's the same as the sine of pi over 4. So there's the first part, simplified to a trig function of a single angle, and then evaluate it. The sine of pi over 4 is square root of 2 over 2. Okay? That's all there is to it for those. All right, so look for the pattern and simplify that way. All right, the ones that a lot of the problems on your quiz coming up, this assessment for for this section in Schoology will be problems like this. You're given some clues about these angles. In this one, the sine of angle alpha is -3/5. The cosine of beta is 8/17. And alpha and beta are third and fourth quadrant angles respectively. That means that alpha's third and beta's fourth. Okay? So, we're supposed to find these different quantities, the sine of alpha minus beta. Okay? Well, the first thing I would do here is write out the expansion. The sine of alpha minus beta is the sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. All right, just write out the expansion from your formula list. And then we got to evaluate, we got to find all these values. Well, some of these we already know. We are given the sine of alpha is -3/5. So this one's going to be replaced with -3/5. I don't have to do any work for that, that was given. And I also know the cosine of beta. That's 8/17. You're going to multiply those quantities together. But here's what we don't know. We don't know the cosine of alpha or the sine of beta yet. So this is where we need good diagrams. And this is the key, is drawing the right diagrams. So, for angle alpha here, we know that it's a third quadrant angle. So I'm going to draw angle alpha in the third quadrant. And I know the sine of angle alpha is -3/5. Sine is opposite over hypotenuse. This would be the -3. This would be a +5. Remember, never put a negative on the hypotenuse, only on the x or y. The missing side of this, it's a 3, 4, 5 family, would be 4, but I'm going to make it negative because I'm moving to the left. That'll help me. This is critical. You need to make sure you put the negative on there. If it's moving to the left, that's negative in the x direction. Moving down is negative in the y direction. So don't forget to put the negatives on there. The most common mistakes are forgetting the negatives there. So, according to this diagram, if I need the cosine of angle alpha, cosine is adjacent over hypotenuse, it would be -4/5. Okay? So it's a -4/5. And do the same thing with beta. Here's my x and y axes. We know beta is a fourth quadrant angle, so I'm going to draw just an arbitrary angle into the fourth quadrant and label it beta. And I know that the cosine of beta is 8/17. Cosine is adjacent over hypotenuse, so 8/17. And that's a +8 because it's moving to the right. 8/17. It's a 15 is the missing side, and that's got to be negative because I'm moving down. So therefore, the sine of angle beta is opposite over hypotenuse, -15/17. And now I just got to do the math, the arithmetic. Multiply these together. -3/5 times +8/17. -3 times 8 is -24. 5 times 17 is 85. Minus a -4 times a -15 is 60 over 85. -24 minus -24/85 minus 60/85 is -84/85. And you're done. Okay, with that one. Now, cosine of alpha minus beta. Write out the expansion. Cosine of alpha times the cosine of beta plus the sine of alpha times the sine of beta. That's from the formula list. Okay? Now, just plug in what we know. We already know all these now. The cosine of alpha was -4/5. The cosine of beta was given as 8/17. Sine of alpha, that's -3/5. Sine of beta, that was -15/17. Okay? If we do the multiplications, we get -32 over 85 for that first one, plus, and then -3 times -15 is +45 over 85. -32/85 plus 45/85 is +13/85. Okay? Now, let's add one here. Okay? What if I asked you to find the tangent of alpha minus beta. Okay, what if I added this one in? You could use the formula, tangent of alpha minus beta, but if you already know the sine of alpha minus beta, and you know the cosine of alpha minus beta, the tangent of alpha minus beta is just sine over cosine. So don't reinvent the wheel here. Use the shortest method possible. You'd get the same answer if you did use the formula, but this is going to be a lot quicker because we already have these two values. Sine is negative 84/85, and the cosine was 13/85. And you can turn that into multiplication by flipping the bottom one over and make it negative 84/85 times 85/13. The 85s cancel, get negative 84/13. Okay, that'd be the quicker way to do the tangent of alpha minus beta in this case. Once I know the sine and the cosine of those angles, sine over cosine is the tangent. Okay, so now, letter C. What quadrant is alpha minus beta in? Well, think about this. The sine of that angle is negative. That has to be third or fourth quadrant. The cosine of that angle is positive. That has to be first or fourth quadrant. The only quadrant there that those both are true is quadrant 4. Because the sine is negative and the cosine is positive. Final example, find the exact value of sine of 255 degrees. Do not go to a calculator. Calculator is going to spit out a decimal approximation. That's going to be wrong. Okay, will not be given credit on a test. You need to change this into either the sum or the difference of two automatics and do this using no calculator at all. So, one way to do this is 255. You could split that up into 225 plus 30. Those are both automatics. You could do 135 plus 120. Those are both automatics. You could do, let's see, a lot of different things, but let's see, 45 and 210. The point is, it doesn't matter which one you settle on, as long as the two angles you split it into are both automatics. I'll do the first one I chose, just because it was the first one that came to mind. So, I'm going to say that's equivalent to the sine of 225 plus 30. 225 plus 30 is the same as 255, but these are both automatics. This is alpha, this is beta. We have sine of alpha plus beta. So the formula for sine of alpha plus beta is the top one on your list. Sine alpha cosine beta plus cosine alpha sine beta. So in this case, it'd be the sine of 225 times the cosine of 30 plus the cosine of 225 times the sine of 30. Sine of 225 degrees is negative square root of 2 over 2. Cosine of 30 is positive square root of 3 over 2. Cosine, and then it's got plus sign. The cosine of 225 is negative square root of 2 over 2. And the sine of 30 is 1/2. If we multiply these together, we get negative square root of 6 over 4 plus, and then this is a negative square root of 2 over 4. So I can combine those into one fraction because they have the same denominator, and it's going to end up being negative square root of 6 minus the square root of 2 all over 4. And that's the way you leave your answer. It's exact when the radicals are there. And there you go. I'm going to do, that'll be it.